So as Jesse said, I'm going to give a quick talk about T and iOS or Swift. Quick about me. I write software. I write software in Swift, Go, TypeScript, and because I do machine learning, Python. There is no other reason to write Python. Once Swift and TensorFlow come together nicely, I will write it in Swift. I play music. This is my band. I ride mountain bikes. As anyone who follows me on Instagram knows, I fall off mountain bikes and end up in hospital quite regularly. Well, not quite regularly. Once every 24 months or so. That one cost me 22 stitches. If anybody would like to go riding at any time, hit me up on CocoaHeads. I know all the best trails. All right. How many here have heard of the Elm Architecture? How many people have actually written anything in Elm? Okay. This will be easy. The Elm Architecture can really, from its simplest perspective, be broken down into one sort of function signature, which is a model and a message produces another model and some commands. That's it. That's the entire thing. That is all that Elm is. It is that simple. Right? It is not a complex idea. There is rendering that happens on the back of that. There's changes to the model. But they're all ancillary to what the core of Elm is, which is model, message, model, commands. Repeat. So what's a model? Well, that's the state of your application. What you want to include in that state, and I'll talk a little bit about that, how specifically that applies to iOS. But in terms of Elm, it's everything. It's the world. What's a message? They're called messages in Elm. I call them events. They're things that have happened. They're not things you want to happen. So if you look at frameworks derived from the same place. So Elm can really trace its roots back to something like CQRS. Any people heard of CQRS? Right, which is basically says, I've got some commands, they're going to cause some changes in the system, I'm going to watch those changes and I'm going to produce a projection, a view, something we can look at, right? And that view doesn't actually need to be something you can look at, it can be some records in a database table, it could be a log to an event, etc. Flux came out of that space, which was the Facebook JavaScript one. Redux was a simplification of Flux, and that's what everybody, that's the best known of these unidirectional, I think, is Redux. So when you go back to CQRS, which is kind of the home for all this, you start to think of events as things that have happened. In CQRS, when you're modeling something, if you're modeling the items in a warehouse and you go into that warehouse and you go to pick something off the shelf and it's not there, right? And I'm trying to clean way of saying this. So it's not there, it's something that has happened. I wanted it. Fetch, go and fetch the thing was the command. I come back, not there, not found is the event, or picked is the event. So message command, it's called message in Elm, but you can think of it as event. Command is purely a home for side effects. It's the only place that side effects happen. What's a side effect? Anything that happens outside of the bounds of your application. Write to a log, call a web service, display something on the screen. They're all side effects. There's stuff that happens outside of the bounds of your control. So about 4 or 5 months ago, I picked up, I do a lot of code reviews on applications, occasionally have to fix them. So I picked up an application, it had no real structure. Had lots of RxSwift and no structure. So I looked around at what architectures were out there. I'd done a reasonable amount in Elm, understood those things, and I was looking for something WeeDux-like or Swift-like that could just control the changes to my system so that then I could, make logical choices about what I wanted to show on screen. Looked at RxSwift and a bunch of other things. I decided none of them did what I wanted, so I wrote WeeDux. It started off as a Redux clone, and then I quickly realised I didn't want Redux. I wanted Elm. And I'll talk a little bit about that later. So the goals were to take that first function I showed you. I've got a message, I've got a state, I've got a message in, I want to produce a new state, and I'm going to produce some side effects. Now, where this is different to Redux is those side effects happen as things come in. Right? So if you look at RxSwift, they've got a thing called func, which intercepts an event and turns it into some asynchronous thing. And if you look at Elm, it happens at the other end. And the other end makes sense to me, because something's happened, now I want to trigger some other things to go on. It also makes it really controllable. Non-goals. I've seen a lot of attempts of taking a Redux-style architecture and converting it into an iOS application, and you always get to the view layer. And you know what? iOS view layer is not going to play nice with a Redux-style architecture, because it wants to control and re-render. So there was never a goal in this to produce something that could render. All I wanted to do was make sure that I controlled the state of the application in a clean manner, and I could observe that state. Everything else, we've got RxSwift, we've got reactive Cocoa to do all those sort of things. The core of Redux, of WeeDux, is a program. It's taken from Elm, and the whole system is 4 methods. Now, if we go back there, you'll notice it's a struct, not a protocol. And it's effectively a witness. So when you compile your protocol adherence, you get a struct. And that struct implements your protocol for your class by shoving the methods in. All that a witness is get rid of the protocol bit, and it makes working with generics. If anyone's ever done type aliases and frickin' associated types in protocols, they're a frickin' nightmare. This makes it trivial, because you're just working with generics all the way through. So you get the same sort of power, except for one thing: you can't compose it. You can't say, I implement 3 of these. Right? But where you just want a protocol that describes some set of recontextualizable actions, a witness works really, really well. The 4 methods. Read. A synchronous method to read the current state. Inside of the application, it's guaranteed to read consistently. It is guaranteed to read. There's no chance of a writer writing while you're reading, because you might have a large tree. It's guaranteed to read synchronously. Not very useful, but useful when without it, there's times where you really need it. Most of the time you'll subscribe, right? And if anyone's done any sort of reactive stuff, I'm going to listen to the changes, right? Model changes, I'm going to get some updates. I can subscribe, I can unsubscribe. Dispatch an event, something's happened, tell the void signature produces nothing. Right? There is no, it's not going to give you a new state, anything like that. It's just going to pop the event into the system. And execute a command. Again, a void thing. Execution of commands. So the other thing I looked around for is, how is dependency injection handled across applications? Dependency is only needed, injection is only needed where you have side effects. Right? We really only need it to put things in that are going to produce side effects. So I made a command execution environment that had access to the external side effect services and produced events. That's all it had. Very simple, but it gave me instantly my fit, because the only place I could produce side effects is inside of a command. All right. So, model and state. It's whatever you want. You can use classes, you can use structs. This is an example struct. I tend to use structs, but there's no reason for you not to use classes. If you think the copy and, if you think your cost of copying structs around is going to be too high, you can be a class just as easily. WeeDux doesn't care. I haven't found a reason yet. I'm running some pretty big stores and sort of these things. I haven't found a reason yet to worry about switching to classes in these sort of things. But if I ever needed to, I'd flip it to a class and just be a bit more careful about how I'm accessing things. You'll notice that in this case, this is an external API, but all these sets are internal, so the only thing that can write to it is the thing that's inside the state machine. Everything else can read the state. Dispatch. If you've used Redux, you'll have heard of used reducers, event handlers, whatever. They take a state and event, they produce a state and some commands. As we can see now from the commands have environments and can produce events. There's a simplification of an event handler, which is a reducer, which is effectively a state to an event and a state to a magic command called none, which is basically something that doesn't do anything. Right? It's still going to produce a command, but it sometimes makes writing things. If you just want to you're not going to have anything with side effects, and you just want to remap over your thing, it's just a state event signature. But that's just a bit of sugar on top of things. What does an event like? I use enums because they work really nice in Swift. Right? I tend to have a marker protocol for all of the types of events, and then I group my events into kind of areas of domain and just make them enums. And a simple reducer, right? We've all seen this in multiple languages. Take the state, take the event in, I check whether the event type is the one that I'm interested in. If not, I'm just going to say, yeah, thanks, don't want to see it. And just return state amount. No smarts in here, by the way. No, hey, registering that this handles this type of event, etc., etc., etc. Because at some point, you're going to write something that handles multiple types of events. And then your infrastructure is playing against you. Right? You can make optimizations higher up in your function stack to eliminate when you do composition of your handlers if you're finding a performance issue there. But if not, this keeps you going nice and easily. Commands. So where an event, if we come back to an event handler, is just a function, command is actually a structure. There are a couple of reasons for that, mostly around the way you can compose them. And to be frank, I'll talk about future stuff, this actually works out a little bit better than event handlers. So they have they're a struct that holds an effect, which is basically something you want to run. And there's the magic none command, which is just, and you can see they kind of write like just functions anyway because of the default initializer stuff. It's just a function of the thing. And there's a much longer version of command. Now, commands can do two things. So in this command, you can see I'm pulling in from the environment the classifier client. I'm making a request. Events all happen guaranteed serially. Commands happen in parallel. There is no order between commands. Commands just execute. Right? Don't wait for each other. If you need them to wait, then use events to trigger other commands, to trigger other commands. And in this case, so I'm going to go off and do something, and at the end, unlike the none, I'm actually going to produce some events. So I'm going to publish. Again, it doesn't know anything about, it's not reading anything globally here. It's only reading data it's got in its function. So it can't escape context. And this starts to become really important when you want to test this stuff. Right? Success and failure, a few result things there. Now we've got results, much easier to handle data across threads, errors across threads. So coming back to a bigger event handler, so we saw a reducer earlier. This is an event that produces a command. So in this case, we've got an event which is an affiliation event. An affiliation's been added. So I'm going to go and write that into my store. And then I want to actually go, you know what, let's just make sure all the affiliations are right from the server. So let's just pop up a side effect, which is trigger a refresh command. That'll get picked up by the system, a fresh command comes out, and away we go. A few little extras. So that's it. It's like 4 methods and a couple of function signatures. I built 2 production applications and 1 in-house application out of this, and it is by far the simplest thing I've ever done as far on iOS for managing my state. Because I've got a couple of little extras that help out. The environment thing is really handy for testing, especially. But it's also just handy because you don't have to have a dependency injection framework. My dependency framework is just a struct with a whole pile of protocol conformances for the services it gives it. That's it, doesn't need to be any more complex than that. Middleware. It's sometimes handy to have a look at events as they come by, right? And do things with them. For instance, so a middleware is just a thing that takes a thing that can read the state and another dispatch function produces a dispatch function. Simple one is logging. I'm going to receive the current state. In this case, I'm going to process the event. So pass it on to the next handler, and then print out that I processed it and what the current state was afterwards. It's kind of handy at times. You can always accept. But you can use this for things like, let's say you've got an affiliation applied event, as we saw before, and I want to add some analytics at that point. I can trigger a side effect at that point to add some analytics. Right? I don't have to put anything into the system. The second thing that makes it really easy, I've got a very simple, it's not integrated with any reactive framework. Why? Because which one's better? RxSwift, RxSwift, you know, I don't care, they do the same job. But it's really simple to adapt this model straight over, to make reading the store straight over to a reactive system, because you've just got to put a little bridge thing in there. So this adds a reactive extension to a program, and now you can just dot reactive and pull on the state and get all these state updates. RxSwift, same sort of thing. Right, so you can bridge it to either the major Rx systems, which are fantastic for getting data from your changes to your screens and doing all the little transformations you need along the way. Quick demo. Now, this may or may not work so well. I don't seem to be able to tab between them. I'm technically challenged here, guys.
Should be.
I broke it. Maybe I need to come out of full screen.
Yeah.
And it's on the wrong screen, but that's all right. We'll just throw it over there. I'll just throw that over there.
Hang on, so let's just go. You coming back to the presentation afterwards, or?
Yeah, just really quickly. I'll just switch the 2 screens and then switch back.
I was going to say, just turn on mirroring here and then turn it off again.
Oh,
when
yeah,
you're
good
done.
idea. This will be interesting. Let's see what happens.
It's still, yeah. There we go.
All right. What have we got going on here? Let's see if we've got network. All right. So there's my little Go server running in the background. So it's just a little Go server running a gRPC server, which goes out and talks out to Store, I think, to get some data. This is a little Mac app I actually wrote this week. So I do a lot of machine learning, and I've got tag images, and all the tools for tagging images are shit. Especially if you want to do multiple tags or web-based, and they take too long. So I just wrote a really quick, started to write a really quick and dirty thing, and I thought, well, I'll make a fairly simple demo. So with all the demo gods, this will run them. Well, these builds are seated, that's a good start. All right. And so I've got the internet. What are the pictures of? So I do melanoma detection. So I'm doing machine learning to do melanoma detection and skin condition detection. So I've got lots and lots of pictures of skin. This is out of the demo set. And one of the tricks is, one of the things we've had to deal with is actually getting good images on a consumer camera and all the things we do. So we've actually got a machine that knows about good images to change the settings on the camera in real time. So it knows when it's looking at a piece of skin and whether it's in focus, whether it's got the right lighting, etc. And it adjusts the gain and the torch and guff like that. One of the problems we came across is that a lot of the images display more than one trait. And only the tagging, the simplest way of doing tagging is to, by the way, that change and everything just went through the WeeDux store. The highlighting and everything you're seeing up here is all through the WeeDux store. So it's all just going straight through the WeeDux store. And if we tab, where do I see run? So I'm not seeing much in there. Hang on. Let me just resize this a bit. And we should see, we don't see events. There are events in here somewhere. I'm not sure why I'm not seeing them. That was a pretty bad demo. I should be seeing, sorry? Yeah. That's where that first event came from. Anyway, so this application, all the highlighting, all the image selection, all the adding and the removing, all the refreshing, etc., is all handled by commands and events and subscribing to the model. And it's really not that much. I mean, that's my entire state of the application. If we look at so tag messages, I've really just got one message, which is a tag's been added. What do I have to write to do that? I write a little function that knows about whether the message is. It's all, what the nice part about it is that you do, everything is in real little things. I'll come to some of the challenges. Oh, there we go. Got some, there you go, the events have decided to show up. Console. But you can see the image selected events going through there with their payloads. All right, so let me just go back to the Prezo because I'm concerned about time. So it was a quick demo. Maybe I'll just do it out of it. All right. Other choice, I kind of spoke about them. I looked at RxSwift. I looked at all the VVV architectures, and I just went, I'm sure there should be a bean in here somewhere. But for really old people, you recognise Java beans, right? The future, there's a few things that... so over the life cycle, it's funny, this started as a CQRS implementation, not an Elm implementation. And if you look through the Git history, there's a spot where I go, yeah, this ain't working, right? Because I had the side effects at the front, not at the back. And when I flipped it over, it changed the world. So a few little things are still hanging on from that side effects at the front system. Event handlers are one of those. They're free form functions, which makes them actually, although I've got methods of composing, they compose as functions. So when you look at a stack trace, it's really long because we don't have tail recursion. Commands don't. They can compose as objects, so I can do things to just create iterators inside of those. So that's probably the biggest change I'll make is to change the command handler. It'll have a zero impact because I'll be able to zero bridge it over from a command function to a struct that takes a command. But as I said, it's running in 2 production applications and 1 not production application. So the handler refactor. Questions? And you can comment if you don't like the question, if you want to comment. Okay.
Was there any questions?
Stunned.
You've stunned everyone, Kev.
I know, it had to be really quick. Trying to fit that into 25 minutes. But I think
Was there a
remember,
GitHub repo? Was
Sorry?
there a GitHub
Yep.
repo for all this?
WeeDux. Once I finish the refactor, I'll actually write the documentation. I'm shy at documentation. But fortunately, Elm has really good documentation, and most of the patterns apply, so there's going to be some refactoring of the Elm documentation because the same patterns apply. I think the thing that I learned from doing this when looking at other things is you can control your state. You don't have to use WeeDux or anything like that, but you can control your state in a really simple fashion. You can have one of these in your application, you can have one for every view controller. It doesn't matter, right? But as long as you control the mutation to your state and your production of side effects, you will be able to write maintainable software. It's really easy to test because everything in there is purely functional. Something in, something out. Every command, even the commands are pure functional because any side effect producing thing is injected via that environment, and you can mock that out and turn it into something that gives you known responses so you can actually test what your part of the system does, right? Irrespective of those licks up. So it makes it really, really testable. In production, it's been really good because I can turn logging on remotely for given users, and I just get a full list of all the events, and I go, oh, yeah, that shouldn't have happened. And I can then take that event log and replay it. Again, persistence. If you make your stuff codable, you can just write out a JSON document. There are some challenges making your events codable, because Apple things don't like to be codable, and if you're dealing with the App Store, you can't, for instance, code your SK product. Right? You can't store your SK product, which you want in an event, because that's the thing you're going to be interacting with.
You mentioned not trying to fight the app.
Right.
You mentioned not trying to fight the UI kit,
Yep.
for example. What does the bridge look like from that kind of thing where an event happens, a bunch of transformations, you get a new model and bind into a new view state?
Let's just try and get rid of some of this. You know what? It's just reactive. So I just leverage reactive strips. So let's go and have a look at a controller here.
Is this the MVV, MMMM?
No, this is just reactive, really simple. Let's have a look at it. So most things have a bind function. So you need two things in order to operate this controller. You need the view to be loaded and the program to be available, right? And then the bind operator fires. And that's just straight reactive stuff. There's nothing in there that's, this may not actually use the program. Oh no, here we go. So just a normal IB action straight off the thing, and I'm just dispatching to the bound program and a tag added event. That's it. So I'm not trying to change the render. We've got RxSwift, we've got Reactive Cocoa for dealing with updates and updating the screens. But none of those deal with the problem of actually how do you manage your model? How do you manage your state? And that's all this does. It just manages your state and gives you easy ways to hook into that. This one might be a little bit better because it'll have some read in it. So this is iOS. All my instructs and iOS, Mac OS, if I want to do the magic binding shit, wants Objective-C objects. So I just have these bindable things that wrap my structs, because I still want to keep my structs elsewhere. Because the convenience of freaking equals and codable, etc. So this is just, again, this is that bridge I put in, you saw earlier where I've just put a Reactive Cocoa Suite bridge in. So program state, got the producer off of that, and then just normal mapping. I'm going to read the tags list from my state. I'm going to map it to a bindable tag. I'm going to sort those tags, and then I made a binding target out of my tag controller, which is a array controller for Mac OS, and bind it in. Again, it's just using stuff that's there. It's not trying to say, well, you know, I've got this really nice reactive changing system, now I want to render it. There's no point. There's absolutely no point, you know. We've got interface builder, we've got all those things, we might as well take care of them. Fighting against them just takes too much time, right? And it doesn't buy you much benefit, quite seriously. And these things are pretty dumb. The shag all business logic in these things, it's all routing logic. I want to, in the case of the previous one, I want to add a tag, or a tag has been added. You know, that's it. It's routing logic saying, hey, I've got all the data, here it is, this tag's added. Make it so. That then gets read via reactive onto this screen. It's just reading the state, reading the tags, popping into the array controller. Magic is handling, getting that into the table view. Standard stuff. Not fighting against that. Not trying to replace that part of the infrastructure. What I wanted was a way of understanding the state of my application. Because when I picked the previous application up, I had RxSwift everywhere, and I could not, for the life of me, figure out how windows were opening and how things were getting set up. It was a nightmare. This can be a little bit verbose, like any functional stuff, and free, and a lot of people don't like free functions. I use a lot of free functions in Swift, but you know, and I use my own little operators for a couple of little things for combination, because I just don't want to write combine, write wraps. I just want to put a few diamonds in and away I go. But other than that, that's all syntactic sugar over four methods, of which you don't have to implement any of them. The whole thing is used internally in WeeDux, uses GCD queues for managing all the locks. So it uses barriers for the writes, and everything else just gets a free roll on the reads. So I can have as many readers as I like and one writer. Multi-reader, single writer. Yeah.
Cool. Were there any other questions? Just one.
This is more of a reactive question. Once you've bound the tags to the binding target,
Yep.
so if you want to unbind, is there a way to do that in reactive Swift?
I've never had to.
Just say argument for, just say if you need to.
If I want to stop the flow of information,
Say you don't want to listen on that tags changing.
for that particular thing,
Just for that.
I'd probably just put you can the reactive. So this is reactive Coca, and I'm more for reactive RxSwift, strangely enough, but I like reactive Coca better after trying it in this out. But you basically unsubscribe,
It's
and
just
that'll drop the connection.
Okay.
Or if you want to stop it temporarily, you just do a flat map latest or a switch latest based on another value coming in,
Right.
and it'll just pause it until you turn it on again, and then you either get all of them or you get the new ones, depending on what you want to do.
Thank you, Kev. Thank you.
All right.